Hi guys, this is a recording for your Unit 2 Albedo formative. I just want to go through some of the information with you and then we can discuss it if you need additional help. Okay, so let's talk about what albedo is. It's the measurement of the amount of reflection of something. So as we know, white reflects. That's why it's easier to wear white during the summer, because it'll actually reflect some of the heat. Or black, so think about asphalt during the summer. It is super, super hot because it soaks in all that solar energy and gets really, really hot. So black doesn't reflect a lot of energy, or if we go pure black, doesn't reflect any solar energy. And as we go down the chain of colors, the closer to white we get, the more it reflects. So pure white reflects 100% of the solar energy that comes in. So this chart right here, 0 represents 0%, 1 equals 100%. So it's kind of the same. So we're going to watch a video real quick about albedo, and then we'll come back.
Positive feedbacks can significantly enhance the rate and magnitude of climate change. One of the most important current feedbacks contributing to climate change is the ice albedo feedback. Albedo is the fraction of solar energy reflected back into space. Ocean water has an albedo of only 0.06, while the albedo of ice is 0.7. This means that the oceans only reflect 6% of incoming solar radiation, while the ice can reflect up to 70%. The rest of the energy is absorbed as heat. Ice has a high albedo because it is light-colored and shiny. When warming occurs due to increasing levels of CO2, more ice melts. Ice cover would increase the Earth's albedo, which would then decrease warming. But because ice cover decreases, less light is reflected back into space, causing further warming. This is a positive feedback. Alongside the ice albedo feedback, other positive feedbacks contribute to climate change. Firstly, melting exposes more ocean water, which is warmer than ice, so releases more heat energy into the Arctic. Secondly, as the ice gets thinner, it can be broken up more easily by winds and ocean currents. And that was sea ice feedbacks in a minute.
Back to this. So again, we were able to look at the measurement of reflection in there. They talked about the dark blue water being closer to black, right? Dark blue is pretty close to black, and it only was able to reflect 6% of the solar radiation that came in. And then they talked about the ice, so the glacial ice, and it was able to reflect about 70% of the light that comes in. So if we go to question number 1, it's giving you a chance to say which one has the lowest albedo. Is it the ice? Is it the grass? Or is it the dark water? Okay, so we'll come back to that one. Okay, so we talked about this also. What causes the ocean global conveyor belt to move? So let's watch a video real quick on how, or an experiment that could help you decide how it moves. Hi, so we're going to watch this video real quick. The red bottle is a container of warm fresh water, and the blue bottle is a container of cold salt water, so salty water. So let's watch and see what happens when she takes the caps off. The blue water is going down, and the red water the fresh red water is going to the surface. Takes a little bit longer for the red one. Okay, so we watched the video. The red water floated to the top. So what did that water, what was its characteristics? It was warm and it was a fresh water. Okay. And then we had the blue that was cold and salty water sank to the bottom. Well, if we go back to the ocean conveyor belt, so this is the ocean conveyor belt, the blue that's right here, that's the ocean conveyor belt start point, is right here. And look at where it's at. It's up by Greenland, it's up in the Arctic Circle, it's very, very far north. So is the water going to be colder or warmer up there? And then this blue that glows around the Earth is a deep, deep water current. So it needs to go from up here, the red is a surface current, so towards the top, in the top 400 meters. And if it's going to sink right here, so what does the characteristic of the water need to be? Is it going to be warm? Or is it going to be fresh water? Is it going to be a high salt concentration and a low temperature? Is it going to be a high freshwater concentration and a low temperature? Or is it just going to be icebergs? So think about the blue bottle versus the red bottle and what their characteristics were. Okay, let's go back to our video that we watched. Okay, so this is what they were talking about. So as the temperature rises, okay, Arctic sea ice melts. That's it. I mean, temperature goes up, ice melts. As that ice melts, it adds water to the system, okay, and back into the ocean. The ocean's dark blue. Remember, it only reflects about 6% of its light. So because it's getting warmer, more light, it's getting warmer, so the temperature is rising. As the temperature rises, more ice melts, which means there's more blue ocean that shows, which means it's taking in more solar energy, which causes more ice to melt. And this circle just keeps on going until there's no ice. And then it'll just be the temperature rises and more solar energy is absorbed, keeps warming the oceans. So it'll just keep going around in circles. So how does the warming albedo affect the density of ocean water? So how does that warming albedo affect it? Does it decrease it because there's fresh water being added to the melting ice? It increases it because water is warming due to a decreasing albedo. It doesn't affect it. It decreases it because more water is freezing due to cold temperatures. Okay. So think about this. So let's go back to this picture. It decreases it because there's fresh water being added from melting ice. Okay, fresh water is being added, but does that have an effect with melting the ice? Does that do anything at this point? Does it have to do with albedo? It decreases it because the water is warming due to the decreasing albedo. Okay, so remember we can go back to our albedo chart. Decreasing albedo is it's moving down towards zero, which means it's getting darker. Okay, so temperature rises, the sea melts, more blue water is showing, and the temperature rises, the Arctic sea ice melts, more blue water is showing, absorbing more solar energy, which increases the temperature. So could it be it decreases because the water is warming due to the decreasing albedo? It doesn't affect it. Or it's decreasing, it decreases it because more water is freezing due to cold temperatures. Okay, based on this, is more water freezing? Okay, so last one. How can a decreasing albedo disrupt the global ocean conveyor belt? Okay, so we have decreasing albedo. That means more area is becoming darker, so more water is opening up for the most part. Okay, so we've learned that the density of the water okay, so we've learned that the density of the water for it to sink, okay, the density of water for it to be able to sink, it needs to be very cold and very salty. Okay, those two needs to happen for the water to sink, causing the ocean conveyor belt. And without that sinking water, you're not going to get that deep ocean conveyor belt. You're not going to get the deep ocean currents. So that leads to deep ocean current. Okay, so that leads to the deep ocean current. Okay, so if we have icebergs or ice in general, so let's say we've got ice. I'm just going to make a picture of a iceberg. Okay, there's the water line. So let's change the color on this one. This is an iceberg. Okay, so icebergs are mostly made out of fresh water because when ice forms, it forms at fresh water freezes at a higher temperature than salt water. So the fresh water is going to freeze. So an iceberg is mostly fresh water. Okay, so it's mostly fresh water. So what is happening is that fresh water is now entering the ocean. Okay. What that does is it disrupts the amount of salt in the water. Okay. When the ice is formed, it's pulling the fresh water out, which is causing it to be salty. When we add fresh water, it decreases the saltiness of the water. So what will happen is the water, because this is happening because of albedo, the decreasing albedo, what is now happening, the fresh water is being added, the salt water is decreasing, it's still cold, but the salt concentration is decreasing, so the water's not going to sink anymore. So it's still cold, but the salt concentration is decreasing. And when that happens, the water can't sink. And that stops the conveyor belt from going. So I hope this helps.